Hello and welcome to another episode of Building Microservices with Go, and we're continuing our series and looking at gRPC. Now in this episode what we're going to look at is gRPC bidirectional streaming. So we're going to take our currency API and we're going to kind of level it up. So why? Why are we interested in doing this? What are the purposes? Well, let's just take a look at our simple example. So in our products API, so products API, when it calls getProduct, what we do is we make a call to our currency API to be able to get the currency. And if you remember from the last episode, that currency API is returning interest rates from the ECB, the European Central Bank. Now we make a call to that currency API with every single request for every product, which, well, it's maybe not that efficient, because if you think about it, what we're potentially doing is that rate isn't going to change that often. In fact, the EACB API that we're using doesn't change very often at all, but it's just not efficient to keep calling that service when the rate isn't changing. So what we want to be able to do is kind of implement a more of a push-based model. So when the rate changes, if I'm using that, if I've got it in my cache, I want the currency service to notify me that there's been a change. And to be able to do that, kind of like that pub sub model, we can use bidirectional streaming. So bidirectional streaming. So bidirectional streaming is a special type of RPC call in gRPC. So if you look at this getRate method here, this is known as a unary method. It has this very, very simple request response model. There's no kind of open connections or anything like that. It's very simple. GetRate is called, you process the request, you return a response, and it just terminates. Exactly the same way as a kind of a standard HTTP handler would work. Now with gRPC and streaming, what we can do is define a method like this. So again, we're going to use that RPC keyword, but let's give our method name. So this time, well, we're going to be subscribing. So let's call it subscribe rates, subscribe rates. Now my method signature, I'm going to use this additional keyword, stream. And stream tells the kind of the protobuf and ultimately the gRPC generation that we're going to be creating a streaming API. Now I can stream messages from the client to the server, and in this case I can do subscribe rate stream and a standard message. So let's just do rate request, and I can also stream messages back to the client just like that. Now I don't have to do streaming both ways. I could just do streaming one way. I could have a single request and a streaming response, or I could just have streaming requests and no sort of streaming response at all. But it's very, very flexible. We're going to look at bidirectional. So we add that. So what do we need to do? Well, we need to rebuild our protobufs. So make protos. Just missing a colon there, semicolon. But we're using that protoc command to build our protos. And what that's going to do is it's going to add a new method onto our currency server interface, which we must implement. So if we look at it here, it says subscribe rates. It has this type parameter of subscribe rate server, which has a send and a receive method, and it expects an error as a return. So this method here and this object is what we're going to use to implement. Now, it's probably going to be easier if I just kind of show you how we go and implement that and explain it as I go along. So let's add that new method. So it's func. We're adding it to the currency. And this is our method signature. It returns an error. So let me just put the package on there. And we'll give it a name. We'll call it source or something. Okay. So subscribe rates. This gives us that currency subscriber server. Currency subscriber server has two methods that we are going to be using. That's the send and the receive message. Now, both of these are kind of going to be handled in this instance. So let's deal with just the send method first. So what I need to do is I'm going to do source.send, and then I can send a message. So it's going to be protos rate response. Okay, so new protos dot rate response, whatever, doesn't really matter. And that has an error message. Okay, so I can just do that. Okay, I'll return that error. Now the thing about this is that if I just kind of do this like this, I'm only ever going to get one message that's going to be sent. Because in order to be able to continually read and continually write to my client, I've got a block inside of this method. It's not something which I just immediately return from. So let's just refactor that a little bit to take that into account. So I'm just going to use a loop. Got my error there, and if my error, obviously, I'm going to return the error. And after I've sent a message, I'm just going to sleep. So I'm just going to put some just dummy code in there for the moment. So let's walk through and take a look at this. So I'm now blocking. Whenever I get a client connection, server is going to come into here. I'm going to be handled with this. I've got this constant loop now. I'm going to send a message back to the client, just a standard rate response message every 5 seconds. So let's see that in action. So let me just build my server, go run main.go, and then we can call it. So to call the server, what I'm going to do is I'm going to use gRPC curl. And I will put a link to the video up there that I recorded on gRPC curl and kind of some more depth on that. But it's incredibly versatile. It allows you to curl both the unary and the streaming. So let's kind of just walking through what's going on here with gRPC curl. I'm using plain text because I don't have TLS enabled. Message template I don't actually need for this call, but that in the instance of doing a describe, that'll show me the sort of the JSON that I want to send. -d and then @ what that means is my data payload for this call is just going to come from standard in. The server, so localhost 1992, the location, and then the service and method that I want to call currency.subscribe rates. And you can see there that I'm calling that. It's a streaming API, and every 5 seconds, I'm getting a new message there. Let me just run that again so it'll just be kind of easier for you to see. But we immediately get the first call, 5 seconds, we get the next one, and then in 5 seconds, we're going to get the next one. There we go. And that's because we're blocking here in this for loop. So let's just kind of quickly, let me just show you what's going to happen if I don't block here. And I'm just going to restart my server. And again, let's just run that gRPC curl. So we get the first request as we expect, but we're not going to get any more. And we're not getting any more because subscribe rates here has exited. So that's why we kind of need a block. So let's just put that back the way it was. Okay. So how about handling the request from the service? So we're kind of showing how we can send, but what about the actual inbound request? How do we handle that? Well, what we're going to do is, again, we're going to use another method on this currency subscribe rate server. And we've got this receive method, and receive has properties. It returns rate request and error. So rate request error, so it's going to be sc dot receive. Now, receive is a blocking method, which means that until the client sends a message, this is just going to block. It'll block forever. So if you've used like net connection or something like that in the standard package, it's exactly the same sort of feature. You kind of do that thing where you're just kind of blocking, waiting for new requests. Now, again, like the kind of the send method, we need to be able to continually kind of loop. So, we want to kind of read all of the messages. So we can just use another for loop there. And we can sort of handle the error message. So if error is not equal to nil, then, well, let's just log an error message. So c.log.error, unable to read from client. And then let's just log the error. So the interesting thing, though, about the error message is that if you get a kind of an error message, just a kind of a generic error, it generally means that something like the connection has been forcibly closed. Could just be it's just been terminated. It's kind of a big error. Now, in the sort of the instance where the client closes, because the client can close its outbound stream and keep the inbound stream open, you're going to get an error message which is io.eof. So I'm just going to say if error equals io.eof, and this isn't technically an error. It's kind of the client has just closed the stream. So we're just going to do c.log. We're going to do info. We're just going to say client has closed connection. And we can just, in both of those cases, we can just break out of that loop. So the kind of the core problem now is that we've got two for loops. So I'm going to be blocking here and I'm going to be blocking here, and I don't want that. So let's just put a go func around the client requests. A go runk, maybe not. A go gunk, maybe not one of those either. Go func around the client request so that we're kind of going to be blocking on the server, but not on the client. So let's now handle that inbound message. So all I'm going to do is I'm just going to log it for the time being. So c.log.info and handle client request. We're just going to do RR. And that's all we need to do. So let's go and let's run that again. So I'm running there, my server. So what I can do is I can kind of call that, but well, what's the payload? So what I can do is I can check out what the payload is. I can say describe, and I can do currency dot subscribe rates. So I can see there that with describe, I'm getting that it has this rate request. So I can just, using that message template, I can just do describe rate request, and I can see exactly what the request is going to be. So that's kind of again, a nice little thing about gRPC curl. So let's run that. So we said that we're using -d at, and that means that we're waiting for standard input in order to be able to receive the message. We can see there that we're kind of all right, nothing going on. Let's just paste in our message. And you can see that we've handled the client request, and that's kind of gone through there. And then let's do that again. And again, you can see that we're kind of handling that client request. So kind of all of those kind of messages, we're just kind of running, whoops, that's not the right place, running through there. So we've got that bidirectional streaming going. What happens if I type this? Oh, there we go. You see, we get a crash because, well, as expected. So that's kind of nice. So we've just kind of set up that very, very basic bidirectional streaming there for our subscribe rates. We can now handle these streaming inbound messages, and we can send those streaming outbound messages. The next thing that we want to do is we kind of want to just go through and implement that as a kind of a full working example. So in the next episode, what I'm going to do is I'm going to look at how we kind of take this bidirectional streaming and we're going to kind of implement the real world meat of it, if you would, into our product API. And we'll kind of see how it works and more really working around that. But for now, thank you so much for watching. Don't forget to like and subscribe. Stay tuned for the next episode. Great.